Our last video introduced the idea of tasks, the core atomic unit by which people use visualizations. While we can see how the idea of task might be important to try to drive the types of visualizations that we create, characterizing what is a good task and what are the sets of meaningful tasks for a particular problem we're trying to solve can be a little trickier. In this video, I'm going to discuss some properties of tasks that you might want to gather from your stakeholders in order to design and optimize the visualizations that you create. So the process of characterizing a data problem according to tasks is conducted using a technique called task elicitation. And task elicitation is essentially just offering us a means to characterize the tasks that a visualization tool needs to support in order to solve a target problem. Typically speaking, the best way to conduct a task elicitation is just to talk with people. We'll typically interview people with domain expertise or conduct surveys of past analyses in the field, or in the optimal situation, we'll do a little bit of both. We'll figure out what are the questions people have answered in the past in a particular area and talk with experts about what they need this new system or this new tool to accomplish. We can deconstruct a task using this who, what, when, why, where, how framework that we teased a little bit at the end of our last video. So the key questions we want to try to answer from our task elicitation all relate to individual properties of task characterization. These questions are: why is a task pursued? This will define the goal of visualization use. How is a task conducted? This defines the means by which people work with the data. What does a task seek to learn about the data? What characteristics, patterns, or properties matter? Where does the task operate? What target data do we need to work with, and what frames of reference are we working within? When is the task performed? What knowledge do people have going into the task, and what knowledge will they have coming out? And what do they do next? And who is executing the task? What are the roles of our users in understanding this data? Again, as a reminder, I strongly encourage that you answer and address these questions before you've even started putting pencil to paper or fingers to keyboard to design and prototype your visualizations. Task-driven design is most powerful when you come at the question without any predefined notion of what the visualization will look like, and you instead focus on what do people need to do with their data. So I want to break down each of these key properties one at a time in the remainder of this video. So the first of these properties is our purpose. Why is a task performed? What are the user's goals? And we typically have 4 common purposes that people engage with visualizations to accomplish. People will often try to explore their data, so they're consuming existing data and information in order to produce new knowledge about their data. Think about this as one of the classical techniques we use business intelligence tools like Tableau for. I have a data set and I want to figure out what's going on. I want to generate new hypotheses about my data. These kinds of representations tend to have a whole lot of interaction because as people explore the data, new questions and new tasks might arise. So integrating deeper suites of interaction will allow users to more readily address these new questions as they come. A closely related purpose is the idea of confirm. So in Explore, we're trying to generate new knowledge from nothing. We're generating hypotheses about what our data tells us about the world. In Confirm, we have a predefined expectation. We have prior knowledge, and we're trying to validate that prior knowledge through our data. 2 fairly different sets of purposes are present and enjoy. So when we're presenting, we're trying to succinctly communicate information. We know the knowledge that we want the audience to get, and we're trying to communicate that knowledge as simply and directly as possible. Data storytelling is a great example of this. Things like we see in the Washington Post or the New York Times, where visualizations are used to present data and present a specific point or argument through data. Presentation is an incredibly powerful application for visualization, but presentation-based visualizations, unlike exploratory visualizations, tend to be much more static. Oftentimes, for example, if we see these in print media, we have no way of interacting with that data other than using our hands to point and to occlude and to guide. When we're thinking about presentation, however, Presentation doesn't have to be static. Interaction can be integrated to do things like increase user agency, allowing users to ask new questions of the data in the process of consuming the point that is being made through the visualization. This is also very closely related to the idea of visualization for enjoyment, which consists of casual encounters with the visualization. Think of this as things like data art, where the visualization builds awareness, but the point of using the visualization is not necessarily to communicate any sort of specific knowledge. It's more about reflection, awareness, and surfacing otherwise hidden patterns or ideas in our data. The next set of questions that we ask about in a task elicitation are means. This is essentially, how is the task conducted? How are users interacting with the data? One quick caveat, interaction is a little bit overloaded here. This could mean the kinds of interactions that we talked about in Module 1, things like panning and zooming. It could also mean, how are people visually processing the information? The kinds of task elements that we typically see associated with means are things like navigation, organization, and relation. When we're navigating, we are moving through the data. For example, we might want to search for data points that we know are interesting a priori and try and find where those are. We can also scan the data for potentially interesting targets, browsing without necessarily having a predefined set of data we're looking for, but rather with the idea that we'll know what's interesting when we see it. Organization is changing how the data is presented. When we're trying to organize data, we're thinking about things like filtering the data, aggregating data to estimate particular statistics, deriving new data, new metrics, new insights into that data. Organizing is essentially a way of allowing the user to group and sort and filter the data in ways that allow them to build new insight or new knowledge into the information that they're trying to build. And this is especially poignant with tasks because it allows users to quickly focus on relevant kinds of information, relevant characteristics of the data that will simplify the process of accomplishing the task. Finally, we have a relation. When we're building relations, we're trying to connect the data. So we're trying to figure out what are the relationships that emerge amongst different facets of my data. So think about this as doing something like comparison. We might compare two groups of data points to look at their distributions or to look for outliers or to assess similarity. We can also discover relationships between variables, things like understanding our two particular dimensions of our data set correlated. And this idea of trying to build these connections, build these relations, finding, for example, where similar data points are across multiple charts, takes us directly into the next aspect of tasks that we would want to characterize in a task elicitation, which is the idea of data characteristics. What does a task seek to learn about the data? This is probably the thing that we most commonly associate with the idea of a task. You can think of this as what are the traditional patterns or statistics that our user needs to be able to assess from the data. We can think of these patterns and statistics at two different levels of detail. We have low-level characteristics, which consider individual points, for example, estimating or comparing specific values where we're working at a low level of detail, high degree of precision, and we might want to think about how that task necessitates certain kinds of interaction or certain kinds of visual channels. And then we also have our high-level characteristics, where we're considering patterns across multiple points, like trends or averages, where we might want to think about how the visualization could scaffold, for example, trend estimation by adding additional reference lines or allowing people to assess and interact with the data and see the visualization and these high-level characteristics emerge as this interaction occurs. For example, we might want to allow people to filter between sets of red points and green points and get rid of all the other information so that they can compare those averages more efficiently. One pro tip that tends to come up at the data characteristics phase: visualization is incredibly powerful. It allows people to flexibly understand and navigate their data and see so much more about their data than any single statistic would. But visualization is not always necessary. Especially in the process of trying to quantify the data characteristics your stakeholders need, this part of the elicitation actually might reveal that your problem is better solved with a database query than it is with a visualization. So do feel free to be flexible. And if someone just says, really what I need to do is I need something that will tell me what the average value is, That is going to be much more efficiently and effectively solved using a database query than it ever will with a visualization. Once we've understood these characteristics, we need to understand, where does this task operate? What data are we trying to accomplish this task with? Are we trying to assess these characteristics over? While on the one hand, you can define the data you care about on the fly using things like selection, when we think about building and looking at this target data, we'll often think about it in terms of one of two types of reference frames. The first of these is an absolute reference frame. In absolute reference frames, our data is compared against some common established standard. Think about this like time or space or geography. We have a good sense of what is happening in the US versus the UK versus India. We know when we say those countries where they are relative to us in terms of geography. So we have an established map that we can borrow from. We also know if we talk about January, February, March, that's not necessarily baked into the data, but we understand what those time references are. So this idea of an absolute reference frame is using these kinds of accepted canonical frames for understanding and contextualizing our data. The alternative to this is a relative reference frame. So in relative reference frames, our data is compared against other data. For example, if I'm comparing the word composition of two texts, I can look at those texts side by side, and the conclusions that I draw are a function of the data itself. They're a function of the patterns that exist in text A or in text B. So in relative reference frames, the space by which we operate on our data is actually defined by the data itself. Tasks are a really useful way of thinking about what are all the sets of visualization constraints that I might need to design for. But one of the things that's really critical to keep in mind is that tasks don't happen in a vacuum. When we're thinking about the when of a task, we're thinking about what knowledge does the user have going into answering this task, and what knowledge and action might they want to do coming out. This is very closely related to a concept in visualization called snowballing. Answering one question might inspire another, which inspires another and another and another, and the process of answering these questions in a particular order allows you to build deeper knowledge into your data. This is all related to an idea called provenance. Provenance defines the history of the tasks that have been conducted. So if I look at averages, and then after looking at averages, I look at things like the distribution, my assertions about distribution are influenced by the conclusions I've already drawn about the averages in my data. So workflows define the expected order of tasks, and they inform how we might put our visualizations together and what kinds of tasks we might design single visualizations for, how we might group those tasks, and how we might provide transitions between different perspectives on our data. If you want to see a really nice meta-analysis of tasks, I'd encourage you to check out the Avocado tool, which you can see the video link for here. Avocado is a tool that's explicitly built to visualize analytics workflows in biology. And there's a great discussion within this video and within this tool about how workflow serves to both support provenance and support knowledge generation to accomplish and build more generalizable and larger scale knowledge than any individual task would on its own. As we think about this idea of workflow, one of the natural questions that arises is, who is conducting the workflow? What is the role of the user? So our roles define the knowledge and goals that this specific person or the specific user that we're conducting the task elicitation for has, and how the tasks translate to outcomes that are meaningful to that user. To put this more simply, our role is who is doing the task and why are they doing it? This takes us full circle back to the purpose of the task. Are we trying to explore data, in which case our role might be an analyst or a scientist who's trying to generate or confirm hypotheses? Or are we trying to present results to, for example, justify a particular business decision, in which case our audience might be someone like a supervisor who has limited time and needs to understand why arguments are being made as quickly as possible? If we're designing for these different roles, we have different kinds of background knowledge, context, and action that might come out of using the visualization that inform the tasks and the corresponding visualization designs that we create. I encourage you all to take a little time for some hands-on practice, in particular in identifying one distinct problem that you can imagine using visualization tools to solve. And I want you to describe this at the top of a slide or a sheet of paper. After you've done this, I'd like you to think about and characterize 2 different tasks using the framework that we've discussed here. How might you design your visualization to accomplish those tasks based on the characterization that you've constructed?